Hi guys, in this video I'm doing example 2 from chapter 6.3, and this is just another example of solving a differential equation. We're going to get a general solution first, and then we'll use the initial condition to solve for a particular solution. So here we have this big mess, xy dx plus e to the negative x squared times y squared minus 1 times dy equals 0, and the first step in solving a differential equation is try to separate out the variables. Get all your y things together on the left side and all your x things together on the right side. So that's going to be what we do. So to make that happen, I think I'm going to subtract the xy dx over to the right side. And that way I'll have my dx over there. And that'll need to be where it ends up anyway. So bringing that over, I got negative xy dx. And then I'm going to divide things across the equal sign. So I got to keep my y squared minus 1 and my dy over there on the left, but I got to get the e to the negative x squared over here. So I can divide both sides by e to the negative x squared. While I'm at it, I can also divide the y over onto the left side, and that'll give me y squared minus 1 all over y dy equals negative x over e to the negative x squared dx. So now you've successfully separated your variables. What I'd recommend now is before you integrate, clean things up. So over on the left side with the y's, I would divide that out and say, well, y squared divided by y is y, and 1 over y is 1 over y. And I think that'll be easier to integrate this way than the way it's given. Over on the x side, if you're dividing by e to the negative x squared, you can turn that into multiplication by e to the positive x squared, and that'll be easier to work with. So dividing by e to the negative is the same as multiplying by e to the positive. And now you can integrate, I think, a little more easily. On the y side, you get 1/2, that's about a half, 1/2 y squared minus the natural log of y equals, and then this is going to require a u substitution. You can, let's see, over here, let's rewrite this integral, pull the negative out. This needs to be 2x so that it fits the u substitution, make that 2x e to the x squared dx. And then to compensate for that 2, let's multiply by 1/2 out front. And so when you integrate that, that's just going to become negative 1/2 e to the x squared, because that could be then u is x squared, and then du is 2x dx. And then the integral is e to the u, which is e to the x squared. Break out your plus c at that point. And once you've gotten to this point, you might look and say, you know what, I don't want to deal with fractions. Let's multiply everything through by 2. And get y squared minus 2 natural log of y equals negative e to the x squared plus c, because 2c versus 1c, who cares? It's still just a generic constant, and we don't know what it is yet. And now you look at this and say, I'm probably not going to be able to get y by itself, because you have a y squared, and then a separate term, you have a natural log of y. So this is a general solution. If you want to get everything on the same side except for the constant, that's reasonable. So I'm going to go ahead and say this is y squared minus 2 natural log of y. I'll add the e to the x squared over. So e to the x squared plus y squared minus 2 ln y equals c. And I suppose this should be an absolute value of y inside the natural log, so let's go back and do that. And that's your general solution. And you can't isolate y and get this into function notation because you have the y squared term, but also the natural log of y term. So now you can plug in values for x and y. You say, all right, well, x is 1, so you have e to the 1 plus y is 0. So e to the 1 plus 0 minus 2 times natural log of 0 equals c. Something's off here. I found my mistake. I copied the problem down wrong. This should be y of 0 equals 1. So the way I had it, this isn't going to solve. So let's go back, try the particular solution again with the correct value for x and y. So 0 is going in for x. That makes a lot more sense. 1 is going in for y. That also makes a lot more sense. And e to the 0 was 1. 1 plus 1 minus 2. Natural log of 1 is 0. So you end up with 1 plus 1 is 2 for your c value. Now, if you didn't multiply through by 2 over here, then your c value would only be 1, because everything would be twice as small. But if you got rid of your fractions over here by multiplying everything through by 2, then your c value ends up being 2. And so then your particular solution, once you put this all together, is e to the x squared plus y squared minus 2 natural log of the absolute value of y plus 2. And at that point, you're done.